Alright, so now we're going to discuss hypothesis tests for population means. It's important to keep in mind that in Chapter 8, we had to look at confidence intervals for population means and population proportions differently. We have to do the exact same thing for hypothesis testing. So, let's take a look at this first example. So, consider the following hypothetical situation. Columbia College has advertised that the mean of their starting salary of graduates is $49,000, okay? An independent organization thinks this is exaggerated, right? That this number is exaggerated, is bigger than it's supposed to be, so they think that the true population mean is less. So we need to conduct a hypothesis test to seek evidence to support our suspicion. So let's state our null and alternative hypothesis. So my null hypothesis is that there's no difference between the stated claim value, right? So my mean is 49,000. And I, in my independent organization, think that the mean is actually less than $49,000. This is going to be a left-tailed t-test, right? Because it's less than, it's going to be a left-tailed. Next, let's say they select a sample of the 100 most recent graduates from college, and the mean salary of the graduates turns out to be $47,000. Now that's less than $49,000, but is it statistically significant? I need to find out. So, how likely are we to select a sample size of n equals 100 with a mean equals 47,000 or less when the mean for the whole population is $49,000? This is bringing it back to the sampling distribution of means, right? I've got $49,000. I have over here $47,000, and I need to know the likelihood of this. This is left-tailed, right? Here's our left tail. I need to find the area in here, okay? So I need to find a p-value, and we're going to do that by calculating a z-score. We're going to look at a distribution of sample means. So, if our null hypothesis is true, then this value over here is going to be less than 0.05. So, here we have our standard deviation for the distribution of sample means. We talked about this in a previous chapter. So to find our z-score, we take our sample mean minus the population mean, right? That's the assumed value, over our standard deviation divided by the square root of n, which is our population size. And again, these equations will be given to you on all exams. So, recall hypothesis test is significant at the 0.05 level if the probability of finding a result as extreme as the one that's actually observed is 0.05 or less, and we assume the null hypothesis is true. So for a left-tailed hypothesis, we would, at the 0.05 level, would need a sample mean of less than or equal to negative 1.645, because here I have, if I have a z-score of negative 1.645, that the area right here is 0.05. Okay, so this standard score represents the critical value for significance in a left-tailed hypothesis t-test. I would always recommend when you get a z-score, going ahead and taking it to the z-table to verify just to be sure. So here we are, Columbia College, okay. How likely are we to select a sample size of n equals 100 with a mean of $47,000 or less when the mean for the whole population is 49,000 and our standard deviation is 6,150, okay? So I'm trying to find the area over here, okay? So let's go ahead and calculate this out. I have z equals our sample mean minus our population mean over our standard deviation in the square root of n. So I have 47,000 minus 49,000 over 6,150 divided by the square root of 100, and I get negative 3.25 as my z-score. So I go ahead to my z-table and I find a value of 0.0006. So there's a 0.00% likelihood of this occurring by chance. So we reject our H naught at the 0.01 significance level. Now, I know that this number is a lot smaller than 0.01, but we can never reject anything at less than the 0.01 significance level. So for a left tail, we look at the area over here. For a right tail, we're going to look at the area over here. And then remember, area is always positive. So we decide whether or not to reject the null hypothesis by comparing the z-scores of a mean to critical values, or taking those z-scores and looking them up in the z-table to determine the area. Okay? The next slide summarizes some critical values. Now, critical values are something you would have to memorize. They will not be given to you on an exam. So I would recommend just always knowing you have a z-score and taking it to the z-table. But here they are. So if you're having a left-tailed test and your z is less than negative 1.645, you reject H naught. And if your z is less than 2.33, you can reject your H naught at the 0.01 significance level. So before, we found a z-score of negative 3.25. So if we come to this chart, we would have seen that we would still reject our H naught. Here are the ones for the right-tailed t-test. Notice that the z-score is just the additive inverse, meaning like the opposite. I've got a negative and I have a positive over here. So remember, the p-value is the probability of obtaining a sample mean as extreme or more extreme than the one already found under the assumption the null hypothesis is 2. Okay? So for a left-tailed p-test, the p-value is the area under the normal curve to the left. For the right-tailed t-test, it's the area under the normal curve to the right, as I'd shown on an earlier slide. When it comes to two-tailed tests, these are special, okay? Two-tailed tests, we want to make sure that the area in both tails adds up to less than 0.05, okay? Because remember, this would be a two-tailed test would be our mean doesn't equal our claimed value. It could be less than, it could be greater than. We don't care as long as it doesn't equal. So we're going to go ahead and work through a two-tailed example. Here are the significance levels for the two-tailed t-test. Again, I would still go to the z-table and know if you have a two-tailed, you multiply your z-table value by 2. So, consider a drug company that seeks to make sure its 500 milligram aspirin tablets really contain 500 milligram of aspirin. Okay? The drug company is interested in the possibility that the mean weight is either less or greater than 500 milligrams. That already tells us we're going to need a two-tailed test. Okay, so let's suppose the company selects a random sample of 100 tablets and finds out those have a mean weight of 500 and what? It's not here. A mean weight of 501.5 milligrams. Okay? We need to find the z-score for this and conduct a t-test. So, I don't have a ton of room. Let's go to another page. My null hypothesis is that my mean equals 500 milligrams. My alternate hypothesis is that my mean doesn't equal 500 milligrams. This red is really angry, isn't it? Okay, let's go to green. I have that my N is 100. That's my sample size. I had a sample mean of 501.5 with a standard deviation of 7 milligrams. So I need to find my z-score. Okay, my z-score is my sample mean minus our population mean over standard deviation divided by the square root of n. So I get 501.5 minus 500 over 7 divided by the square root of 100. That equals 1.5 over 0.7, so I get 2.14. Okay, so I can look this up in a z-table, and I would find that I have a z-table value of the area from 2.14 standard deviations away from the mean. It's 0.9832. So that means over here I'd have an area of 1 minus 0.9832, which equals 0.0162. But this is a two-tailed t-test. So I'm going to take this area, multiply it by 2, and I find that I get 0.0324. So I can reject H naught at the 0.05 significance level because 0.0324 is less than 0.05. Now, there are some common errors that we come across in hypothesis testing. So a type 1 error occurs when H naught is wrongly rejected. Okay, so this would be the equivalent of wrongly convicting an innocent person. Okay, a type 2 error is when we wrongly fail to reject. Okay, this would be equivalent to finding a defendant not guilty when they were guilty. So if I reject the H naught and my H naught is true, that's a type 1 error. If I do not reject the H naught and my H naught is true, then I made a correct decision. Good job. If I reject the H naught and my H naught is not true, that's a correct decision. And if I do not reject my H naught, but my H naught is not true, that's a type 2 error. So let's talk through this. So for our pharmaceutical company example, okay, if the company would reject their null hypothesis and conclude the mean amount is not 500 milligrams when it really is, this would be a type 1 error. And the company would have a type 2 error if they fail to reject their null hypothesis when in fact the mean was not 500 milligrams. So they should have rejected their null hypothesis.